In this video, we will take a look at how SecuCheck works and the features it offers to developers and security analysis writers. SecuCheck is a static application security testing or SAST tool that detects taint-style vulnerabilities in source code. The tool is deployed as a plugin for Integrated Development Environments or IDE and provides an interface to configure and execute analyses. To use SecuCheck to identify potential software vulnerabilities, a specification that outlines the taint flow that the analysis should identify in the provided source code needs to be provided. The specifications are written using a Java internal domain-specific language called FluentSQL. A developer or analysis writer can either define their own specifications or use predefined specifications in SecuCheck's catalog to detect vulnerabilities. SecuCheck's taint analysis uses a program analysis framework called Suite to analyze the source code, and either of two analysis solvers can be used, namely Boomerang based on synchronized pushdown systems or FlowJoard, which uses the IFDS framework. The analysis runs within Magpie Bridge, a general approach for integrating static analysis into IDEs and editors. After the analysis completes, the findings are reported in the IDE. Let's now take a look at SecuCheck in action using a demo project. We will work with a Spring Model View Controller or MVC to-do list application that allows users to create, edit, and delete tasks. For this demo, we will work with Eclipse, but a similar approach applies when using other compatible IDEs. Let's say that we want to identify potential SQL injections in the project. An SQL injection is possible when user input isn't checked or sanitized before being used in a database operation. For such a vulnerability, we want to identify if data from a source method where user data enters the program flows to a sync method where data leaves the bounds of the system. In this scenario, the source method is database controller showTasks, being that this method provides us with the pattern that the user entered in the HTML form. The sync method would be database controller getSearchQuery because this method is used to query the database. Let's now use SecuCheck to confirm if there are potential SQL injection vulnerabilities within the project. In the FluentSQL query, we specify the source and sync methods, the error message that should be shown if a vulnerability is found, and the location in the editor where the finding should be marked. When we open the project in Eclipse, a configuration page is automatically loaded within the user's default web browser. On the configuration page, we can select the specifications we wish to execute, the entry points which the analysis should use as starting points when searching for taint flows, and also the analysis solver. After clicking Run Analysis, SecuCheck starts executing its taint analysis, which runs on the Jimple intermediate representation generated by Suite from the Java bytecode. When the analysis completes, detected taint flows are returned and the results are shown in the editor using line markers. Now we have a marker next to the definition of the source method, database controller showTasks, as well as the site where the sync method database controller getSearchQuery is used, which means that the analysis detected a data flow between the two methods. SecuCheck also translated the FluentSQL specification into natural language in order to provide a better explanation for new users. In addition to the line markers, we can also view a summary of all findings in the problem view. As we have seen, analysis writers and developers can use SecuCheck to identify potential vulnerabilities in their programs. SecuCheck is available as an open source tool, and further details about the tool and its research background can be found in the video description.